USB port is part of almost every electronic device that we use today. This familiar port is undergoing a dramatic change to a new standard called USB Type-C or USB-C. And Fairchild is ready to help you make that change in your designs with a complete USB Type-C portfolio, which is all about flexibility, small form factor, and low power consumption. Hi, I'm Eric Meyer, Senior Applications Manager for the USB product line at Fairchild Semiconductor. Today, we will look at the many benefits of the new Type-C connector, and I will show you how to quickly and effectively implement it using two of Fairchild's Type-C port controllers. The USB Type-C connector packs twice the charging current and more universal functionality compared to current USB implementations. For designers looking to quickly take advantage of this new connector and wanting little impact to their board space or system power, the FUSB 301 is an ideal solution. Let me show you how the USB Type-C connector works. Here I have an evaluation board with both the FUSB 301 Type-C port controller and the FUSB 340 USB 3.1 SuperSpeed MUX. I also have a USB Type-C charger and a USB 3.1 hard drive with a USB Type-C adapter cable. The FUSB 301 can be configured to match all the port types that the Type-C connector supports. For this demonstration, I will select a DRP or dual role port. A dual role port is one capable of sourcing or syncing power based on what is attached, in addition to being the USB host or device from a data perspective. I will now connect the Type-C charger to the evaluation board. As you can see here, the FUSB 301 has detected the orientation through the CC1 channel. It is also indicating that the charger is capable of sourcing 3 amps of power, and it is connected to a source. If I invert the connection, you will now see the only thing that has changed is the orientation is now through CC2. It continues to show that the charger is capable of sourcing 3 amps of power and continues to be connected as a source. Without changing any of the configurations on the FUSB 301, I will now attach the Type-C hard drive. As you can see here, we are connected to a sync now instead, and the connection is through the CC1 channel. You will also see that the hard drive is now visible in my PC. If I invert the connection, the results are similar. The FUSB 301 and FUSB 340 work together to detect the connection and route the SuperSpeed signals properly, independent of how the connector is inserted. As you can see here, the FUSB 301 is drawing only 6 microamps of current while handling all the Type-C detection and control. Let's dig a little deeper and make the same connections with the FUSB 302 Type-C port controller with power delivery. USB power delivery is a recent protocol that becomes much more exciting with the new Type-C connector. The FUSB 302 is configured as a dual role port just like the FUSB 301. When I connect the Type-C charger, the FUSB 302 reports the same things. It is connected as the sync and indicates that the Type-C charger is capable of providing 3 amps of current. But if you look at the power delivery, you notice that we are now at a 12-volt contract. Let's look at what happened. Power delivery, or PD, is a communication protocol designed to manage power between a source and a sink. Here, the source is telling the sink what capabilities it can provide. In this case, the charger is capable of 5 volts, 12 volts, and 20 volts, all at 3 amps. The second thing that happens is the sync, in this case the FUSB 302, requests which capability it would like to have. For this insertion, we selected the second capability, which is 12 volts. The source then can either accept or reject that request. It accepted the request. At that point, it ramps the power supply to the new voltage and indicates to the sink when it is ready by sending a PS ready message. We are now operating at a 12-volt contract. If we wanted to select a different voltage, we could make a new request. In this case, we'll request 5 volts. There is more to power delivery than just the power negotiation. Let's look at this HDMI dongle with a Type-C connector. Once a power contract is in place, devices are free to use vendor-defined messaging, or VDMs, to identify and configure alternative modes which opens an almost endless possibility for the Type-C connector. If I connect the HDMI dongle, the FUSB 302 will report that it is attached as the source and communicating on the CC1 channel. We are also in a 5-volt contract, but there's more that's happened. In addition to the power contract that we saw with the charger, there are now new commands. The first command is Discover Identity, both a command and a response. This is the way a device like the FUSB 302 can identify what was connected. Once it identifies what's connected, it then tries to determine which vendor made the device. This is done through the Discover SVIDs command and response. As you can see here, 2 different IDs were reported. One is the standard ID for DisplayPort, and the other is a vendor ID. Once the device understands what was connected and who made the device that was connected, it then can determine which modes this adapter supports. This is done through Discover Modes and Response, and this allows various devices to all work together. Once it understands which modes it supports, it is free to then enter and exit those modes as needed. Clearly, the USB Type-C connector enables much more than just a universal, reversible connector. The FUSB 302 Type-C port controller with power delivery is specifically targeted towards designers who want to take advantage of the higher voltage charging, high-definition video, or other possibilities with the Type-C connector, all in a space-saving package. For more information and details on the full USB Type-C portfolio, go to fairchildsemi.com/USB Type-C. I'm Eric Meyer. Thanks for your time today.